General Chemistry 1, Chapter 2, The Components of Matter. As we mentioned before, when sodium and chlorine are put together, sodium may lose the electron to chlorine to form a sodium positive charge and chlorine negative charge. The positive sodium negative charge attract each other to form ionic bonding, and this compound is called ionic compounds. Now there's another type of bonding called covalent bond. Covalent bonds form when elements share electrons, which usually occur between nonmetals. So the electron does not lose from one atom to another atom. Instead, it's shared between the two atoms. So here shows two atoms before they react. And so each atom has a proton and the electron, proton and the electron. All right. So when they approach each other, the electron that belonging to A atom is attracted to the proton of B. Similarly, the electron of atom B, so this is B, is attracted to the proton of A. And the optimum distance is obtained when the attraction force between proton-electron balance the repulsion force between proton-proton, electron-electron. And when the optimum distance is obtained, the two electrons now are shared between A and B. And this kind of bonding is called covalent bonds. Most covalent substances consist of molecules. Molecule is the basic unit of molecular element or covalent compound. For example, in water, there are many water molecules. Okay, so HOH, this is one water molecule, and there's another one, and there's another one. So within each molecule, there are two covalent bonds between hydrogen-oxygen and hydrogen-oxygen. So two electrons sharing between two atoms. Now, between molecules, the interaction is called intermolecular interaction. Intermolecular interactions are usually very weak. Ionic compound, on the other hand, consists of regular array of alternating positive-negative charged ions. For example, in sodium chloride, we have sodium positive charge. So around the sodium positive charge, there's a chloride negative charge. And then next will be sodium positive charge, and then chloride, and then sodium. So chloride has another sodium here, and then chloride here, chloride here. So it's just along three dimension, okay, an infinite array of alternating positive and negative charged ions. Even the tiniest visible grain of table salt contains an enormous number of sodium and chloride ions. Now, the ratio of sodium and chloride is 1 to 1. So we can write sodium chloride, but in effect, there's no molecule in ionic compounds. It's the infinite array of positive charge, negative charged ions in ionic compounds. Elements that occur as molecules are nonmetals. These include group 7, group 6, group 5, and hydrogen in group 1. In group 7, elements appear as diatomic molecules. Diatomic means two atoms combined form a molecule. So fluorine, chlorine, bromine, iodine. Group 6, oxygen appear as a diatomic molecule, but sulfur and selenium appear as octatomic molecules, means 8 atoms combine to form a molecule. In group 5, nitrogen is diatomic, phosphorus is a tetratomic molecule. Group 1 are all metals except hydrogen. Hydrogen is a diatomic molecule. It's a non-metal. Many ionic compounds contain polyatomic ions, which consist of 2 or more atoms bonded covalently and have a net positive or negative charge. For example, the crystalline form of calcium carbonate occurs on the atomic scale here as an array of polyatomic carbonate ion, so carbonate with calcium ions, positive charged calcium ions. The carbonate ion, okay, here is enlarged one, consists of a carbon. So here the center is the carbon atom covalently bonded to 3 oxygens. So oxygen here, oxygen here, oxygen here. The 2 additional electrons give the ion its 2 negative charge. In many reactions, the polyatomic ion stays together as a unit, and here is the carbonate ion. A chemical formula consists of element symbols with numerical subscripts. For example, H2O represents a water molecule. The chemical formula indicates the type and the number of each atom present in the smallest unit of a substance. Next, we are going to learn how to write the names and the formulas of ionic and covalent compounds, and how to calculate the mass of a compound from its formula. Here shows how to name binary ionic compounds. For all ionic compounds, the name of the formula lists the cation first, anion second. The name of cation is the same as the name of the metal. The anion, okay, so cation is the metal name. Anion is named by adding IDE to the root of the non-metal name. So when you mix calcium and bromine, for example, because calcium is a metal, so it will lose electron to form a cation, and therefore you list calcium first. Okay, the name is the same as the metal name. Now the non-metal bromine, you add IDE to the root, so remove INE by IDE, so you get bromide, and therefore the compound, ionic compound, is called calcium bromide. Similarly, when you add the sodium and the chlorine, right, the compound should be sodium chloride. Okay, so chlorine becomes chloride. It is very important you spend time to memorize the charges of some common monatomic ions of the elements. Group 1, Group 2, Group 3, these elements, they form ions with charge equal to the group number. For example, sodium is group 1, and the charge will be positive 1, and that equal to number 1 group. Magnesium 2+ equals to group 2 number, and aluminum 3+, so the charge 3+ equal to 3 group number. Okay, the reason, as we already showed before, they want to achieve the noble gas structure. So here is the neon, okay, and sodium has 1 more electron. It needs to lose the electron, becomes neon structure, and so that's why it's 1+. Magnesium has 2 more electrons than neon, and therefore it needs to lose 2 electrons. Aluminum has 3 more electrons. It needs to lose 3 electrons, and that's why it's 3 plus equal to group number. Okay, so these are the main group elements for the main group element for metals. For the non-metals, 5, 6, 7, group number 5, 6, 7, they also want to achieve the noble gas structure, but they are closer. For example, fluorine, fluorine has 1 less electron than neon. Neon has 10, fluorine has 9, so it needs to gain 1 electron, and therefore the charge is -1. And also you can see the group 7 plus 1 equals 8. So 7 plus 1 equals 8. And therefore fluorine, chlorine, bromine is -1. Oxygen, sulfur, group 6, 6 plus 2 equals 8. And the charge is -2. And the nitrogen, group 5, so 5 plus 3 equals 8. And therefore it's -3. Okay, so these are main group elements. Now the group 4, as we showed before, it's the boundary, so it can lose or gain. Now here we show that these are metals, tin and lead. They have variable charge. Okay, the variable charge has 2 possibles. One is 2 plus, one is 4 plus. Okay, so both tin lead has 2 possible charges. Now what about carbon, silicon, germanium? Those form covalent bonds, and so they don't lose or gain electron. All right, so we are not covering here, but there's a chapter about organic chemistry based on carbon. All right, now let's look briefly look at the transition metals. So transition metal group 1, so the 1b group 1, they also have charge 1 plus. Okay, you see silver 1 plus, copper 1 plus, just like main group elements, lithium group 1 1 plus. Okay, here also 1 plus, but sometimes they have variable charge. For example, copper can also be 2 plus. Now group 2, 2b, zinc only 2 plus. All right, cadmium only 2 plus, mercury 2 plus, but also can be 1 plus, and it has to be combined together. So 2 mercury together 2 plus, each one is 1 plus. Okay, now 6, 7, 8. So these elements, the ions usually has variable charge, so it can be 2 plus or 3 plus. So chromium can be chromium 2 plus, chromium 3 plus. Manganese only usually 2 plus, but also maybe other charges. Okay, so in summary, main group elements for metals, all right, group 1, 2, 3, they have charge equal to the group number. Non-metals 5, 6, 7, they have negative charge, and their charge plus group number equals 8. So nitrogen 3 negative, oxygen 2 negative, fluorine 1 negative. Here summarize the common monatomic ions. Again, group 1, whether it's main group elements or transition metal, and the charge is positive 1. And group 2, okay, positive 2. So same number as the group number. Group 3, charge positive 3. Note that the name is the same as the metal. So lithium, sodium, and cadmium. Okay, so same name. Now for non-metals, group 7 is -1. 7 plus 1 equals 8. But also notice the name change. Fluorine becomes fluoride, IDE. Iodine becomes iodide, IDE. Okay, so they all have IDE for non-metals. All right, and the oxygen becomes oxide, sulfur becomes sulfide. Okay, and the group 6, this is group 6, and the charge is -2. And group 5, nitrogen nitride, -3. Now hydrogen, has 1 electron, so it can lose electron, becomes +1, okay, or gain electron, becomes hydride, okay, -1. Okay, now one thing you may confuse. Sometimes we say +2, sometimes we say 2+. Okay, now I personally think that you can say both when you say the charge. So what is the charge for magnesium? It can be, you can say 2+ or +2, but when you write the formula, okay, you must write magnesium 2+. Sample problem 2.8. Name the ionic compound formed from each of the following pairs of elements. To answer this question, we need to use the periodic table to decide which element is the metal and which one is non-metal. The metal, iron, is named first, and the non-metal, you need to add IDE to the root. Okay. Here's the answer. Magnesium, group 2 metal. Nitrogen, group 5 non-metal. The name should be metal, iron first, magnesium, and then non-metal, IDE, nitride. So magnesium nitride. Second one, cadmium is a metal, iodine is a non-metal. So cadmium iodide. Okay, note IDE, iodide. And next one, strontium is a metal, fluorine is a non-metal. So strontium fluoride, again IDE. Last one, cesium is the metal, sulfur is non-metal. So cesium sulfide, IDE. Sample problem 2.9. Write empirical formulas for each of the compounds named in sample problem 2.8. So these are the names, and we want to find empirical formula. Okay, so to do that, we need to find the smallest number of each ion that will produce a neutral compound. Okay, so here is how we do it. In A, magnesium nitride, magnesium is group 2, so charge 2+. Nitride group 5, so 3 negative. To make positive charge equal to the negative charge, 2+ needs to times 3 to give 6+, and 3 negative needs to times 2 to give 6 negative. So both have the same charge, but one is positive, one is negative, cancel each other. All right, so the formula then should be magnesium 3. So you need to times 3 for magnesium to give you 6+, and nitride needs to have 2 nitride, so that the negative charge is 6 negative. Okay, so 3, so you times 3, that's the smallest number for magnesium. You times 2, smallest number for nitride. All right, so give you a neutral compound. Next one, cadmium iodide. Cadmium is transition metal 2b, so it's also 2+. And iodide is group 7, so it's 1 negative. So how do you make positive negative charge equal? In this case, you can keep positive charge, but the negative charge you need to times 2, so that it becomes 2 minus. So 2 minus 2 plus equal. Okay, and therefore the formula should be cadmium iodide 2. Okay, so both has charge 2. Next one, strontium fluoride. Strontium is group 2, so again it's 2+. All right, 2+ here. Fluorine is a group 7, so it's 1 negative. Again, you keep 2 positive. In this case, is positive 2+. You keep it, and the negative you need to times 2, so that it becomes 2 negative. So 2+, 2 negative, and therefore the structure should be, formula should be strontium fluoride 2. Okay, last one, cesium sulfide. Cesium is a group 1, so 1+, and the sulfur is group 6, so it's 2 negative. All right. So in this case, you keep 2 negative, but change positive times 2. So both becomes 2, 2 plus, 2 minus. All right. So in this case, cesium is the one you need to times 2, and therefore the formula should be cesium-2 sulfide. I already pointed out that some elements form variable charges. Now remember, main group elements usually have fixed charge. For example, group 1, 1A, charge positive 1, right? Group 2A, always charge 2 plus, okay, or plus 2. For example, calcium 2 plus, right? And group 7, so for example, iodide is 1 negative, okay? So so always 1 negative and oxygen 2 negative. So that's main group elements. All of them has fixed charge except group 4. So group 4 are the exception. Tin, lead. Okay, these two are exceptions for main group elements. They have variable charge, either 2 plus or 4 plus, 2 plus or 4 plus. Okay, the common name for tin 2 plus is stannous. For 4 plus is stannic. Okay, so that's about the main group elements. Transition elements, on the other hand, most of them have variable charge. Okay, for example, let's look at group 1b. So this is 1b. Okay, in 1b, there's one element that has a fixed charge, and that's silver. Silver form 1 plus. On the other hand, copper form 2 possible charge. One is 1 plus, one is 2 plus. Okay, what about the 2b? So let's see. 2b is the mercury, so 2b. So in 2b, there's also one that has a fixed charge, that's copper. So copper usually, zinc. Zinc usually form 2 plus. Remember that. In 2b, zinc is a transition metal, has a fixed charge. But mercury, on the other hand, can be 2 plus, can be 1 plus, but always combine another together. You should write mercury 2, 2 plus. Okay, that's 2b. So others, group 6, group 8, okay, so chromium, for example, chromium, cobalt, iron, and many others. They have variable charge, usually 2 plus, 3 plus, 2 plus, 3 plus, 2 plus, 3 plus. Okay, so please spend some time to memorize these charges, variable charges. Again, in this table, we show that for variable charged ions, sometimes they have common names. So tin 2 plus, stannous, and tin 4 plus, stannic, and mercury 2 plus, mercuric, and mercury 1 plus, mercurous, and iron 2 plus, ferrous, iron 3 plus, ferric. Okay, so you can keep going. Now, do we have a systematic way to name the variable charges? And the answer is yes. We use parentheses and a Roman number. So for 2 plus, and this is Roman number 2. For 3 plus, you put Roman number 3. So you have a parentheses, Roman number to represent the charge. Sample problem 2.1. Give the systematic name for each formula or the formula for each name for the following compounds. Now this question is similar to the previous one, that to answer the questions we need to find the smallest number of each ion that produce a neutral formula. In A, tin fluoride. So here we have parentheses Roman number 2 that indicates the tin has a positive 2 plus. Okay, because tin has a variable charge 2 plus or 4 plus. Here the name must specify the charge if it has variable charge. And fluoride, we know it's negative charge, 1 negative. Okay, so how do you make positive negative charge the same? So 1 minus must times 2, and therefore you know fluoride must have 2 of them, and so the formula should be tin fluoride 2. Okay, next one, chromium iodide. Now chromium also has variable charge, either 2 plus or 3 plus. Now formula tells you you have 3 iodine. Now each iodine has 1 negative because it's group 7, so it's 1 minus. Now you have 3 of them, so the total negative charge is 3 negative. And therefore that indicates chromium must be 3 plus, so that positive negative have the same charge. Okay, and so therefore we know chromium is 3 plus. When you name a compound with a variable charged ion, you must specify using Roman number. Okay, so here you should use 3. Okay, chromium 3 iodide. Okay, so you use Roman number in the name to specify the charge, not formula. In formula, you don't need to use Roman number. It is in the name to specify the variable charge. Okay, next one, ferric oxide. So ferric is a common name for iron 3 plus. Okay, oxide O2 minus. All right, so group 6 fixed charge. So one is 3 plus, one is 2 negative. How do you make charge the same, positive negative same? 3 plus must times 2, and 2 negative must times 3, and therefore the formula should be iron 2 oxygen 3. Okay, note that iron 2, not 3. Even though you have 3 plus, you don't, here is not 3, but 2, because you need to times 2, so that the charge is 6, and this is also 6. So they have the same number of charge. Okay, oxygen needs to times 3, so times 3 here. Last one, cobalt sulfide. Okay, so cobalt sulfide is 2 negative. Okay, and from the formula you can see this is 2 negative, and cobalt has 2 possible charge, 2 plus, 3 plus. Now if sulfide is 2 negative, then cobalt must be 2 plus, and therefore we know the formula, the charge for cobalt is 2 plus. We use Roman number in the name to specify 2 plus. So the answer is cobalt 2 sulfide. As we mentioned before, sometimes 2 or more atoms covalent bonds together to form an ion, which is called a polyatomic ion. In polyatomic ion, the atoms stick together and serves as a unit. Okay, for example, 1 nitrogen, 4 hydrogen bonds together with a positive charge and called ammonium. So this is a cation, just like sodium cation. All right, this all bonds together as a unit with a positive charge. Similarly, you already know, okay, H3O plus is called hydronium ion. All right, and CH3COO, they all bond together with a negative charge, and that is called acetate. Acetate is an organic anion, comes from vinegar. So vinegar is CH3COOH, and this is vinegar, also called acetic acid. When this acid deprotonates this hydrogen, and it forms CH3COO minus, and which is called acetate. Carbon nitrogen with a negative charge called cyanide. Hydroxide, hydrogen, oxygen bonds together with a negative charge, hydroxide. I'm sure everyone knows this one. This comes from water. So when water deprotonates, it gets hydroxide. Okay, so it seems that we have a lot of polyatomic ions to remember, but in fact you only need to remember some of them. Others you can expand by some rules. The rule is that you find some root. So for example, Cl, okay, ClO3 negative, and this is called chlorate. This is the one you need to memorize. It's called chlorate. Note the ending is ATE. When you see ATE, okay, that's a root. And if another anion has one oxygen less, okay, so let's start with ATE. When have one oxygen less, then it's called ITE. So you see here, that's ClO2 negative. That's one oxygen less than chlorate, and that's why it's called IT, chlorite. Okay, if two oxygen less, then it's called hyper. So now it becomes hyper ITE, hyperchlorite. So you see these three, all you need to remember is this one, the root, chlorate. So if you know ClO3 negative is called chlorate, then you know ClO2 negative is chloride, ClO minus is hyperchlorite. Now what if you have one oxygen more? So for example, ClO4 negative. Okay, so the root is ATE. You have one more oxygen, and that is called perchlorate. Okay, still ATE, but you add per. Okay, so this is called perchlorate. All right, so you start with ATE, one less oxygen ITE, two less oxygen hyper ITE, one more oxygen per ATE, so perchlorate. Now let's look at these two. So the root is nitrate ATE. So you need to remember NO3 negative called nitrate. And this one has one less oxygen, so it's called nitrite ITE. Okay, let's look another one. Phosphorus. Okay, these two. Okay, the root is sulfate. Okay, this is sulfate, SO4 2 negative. So SO3 2 negative is called sulfite ITE, one less oxygen. Okay, sometimes a ion has a hydrogen bonds together. So this is carbonate. So carbonate, and this one called bicarbonate. Okay, not always use bi. For example, these two, phosphate ATE with one hydrogen is called hydrogen phosphate. Okay, this is more common, hydrogen phosphate. Now this is a common name, bicarbonate with hydrogen added to carbonate. Now this is a chromate. Okay, when you have two chromium, 7 oxygen, that's dichromate. Okay, all right. Here shows the rules we already explained in the previous slides. So the root ATE, okay, if you remember this one, now if you see one oxygen less, that's called ITE, and if you see 2 oxygen less, then hyper ITE. If you see one oxygen more, then per ATE. Sometimes a molecule contains water molecules, and that's called hydrate. For example, magnesium sulfate contains 7 water. So always combine 7 water. Okay, so how do you name this compound to specify 7 water molecules? Now in the name we use prefix. If you have 7, we say hepta, so it's heptahydrate. Okay, if you have one molecule, one water, you say monohydrate. Di, tri is 3, tetra is 4, 5 penta, 6 hexa, 7 hepta, 8 octa, so octahydrate, and nona is 9, 10 is deca. Sample problem 2.11. Give the systematic name for each formula or the formula for each name for the following compounds. So the first one is you have iron, cation is iron, anion, ClO4. From last the table, we know that ClO3 negative is called chlorate. So we have one more oxygen is perchlorate. So this is a perchlorate with one negative charge. Okay. Now you have two of them, so the total negative charge is 2 negative, and that indicates iron is 2 plus. Okay, remember iron is a variable charge, has a variable charge, so 2 plus, 3 plus, and here formula indicates is 2 plus, and in the name you must specify 2 plus by Roman number. Okay, so the name should be iron 2. Okay, note Roman number 2 to specify iron perchlorate. Okay, now remember Roman number only used to specify ions with variable charge. If it's fixed charge, for example sodium, all right, sodium chloride, let's say, you don't say sodium 1, okay, because the charge must be 1, it's group 1. Fixed charge, no variable charge, so don't use Roman number. Only for variable charge, okay, transition metal, or main group elements, tin, lead, okay, those are variable charge. You need Roman number to specify the charge. That's the A. Now let's look at B. Sodium sulfite. Sodium, again, group 1, so 1 positive 1, so let's say positive 1 charge. And the sulfite, ITE, we know sulfate is SO4 2 negative. Okay, if you look at the table, 1 less oxygen, SO3 1 negative, so that's called a sulfite. All right, and therefore now also note that 2 negative, because sulfate is 2 negative, sulfite also 2 negative, and sodium 1 plus, therefore you need 2 sodium. Okay, so the formula should be sodium 2 sulfite, okay, SO3. Okay, so that is 2 negative, and now this becomes 2 positive. Last one, barium. Okay, you should remember this is called hydroxide. All right, now so barium hydroxide, barium is fixed charge, so you don't use Roman number. But we also see 8 water. So how do you specify 8 water in the form in the name? We use octahydrate. So the name should be barium hydroxide octahydrate. Sample problem 2.12. Explain what is wrong with the name or formula at the end of each statement and correct it. In A, we have cation positive charge barium, anion C2H3O2. Now in previous slides, we showed polyatomic ion. One is CH3COO negative. This is called acetate. Okay. Now if you count how many carbon hydrogen, you will see in this acetate anion, you have 2 carbon, you have 3 hydrogen, and you have 2 oxygen and negative charge. So C2H3O2 negative is also acetate, and therefore this is acetate. Okay, now acetate has 1 negative charge. Barium is group 2 metal, so you have 2 plus. To balance the charge, you need 2 of them, 2 acetate, and that's why you have 2 here. Now the name given is barium diacetate. Di is a prefix to tell you you have 2 acetate here. The problem is a prefix is only used for covalent compounds. For example, CO2. When you name it, you name carbon dioxide because you need two of the prefix 2 to say you have 2 oxygen. Now for ionic compound, prefix is not used. But how do you know which one is covalent, which one is ionic? In question A, we have a barium, which is a metal, okay, group 2 metal, and acetate is a polyatomic ion, which is a non-metal. Well, so metal lose electron, non-metal gain electron, and that is a ionic compound. In CO2, both carbon and oxygen are non-metal. Okay, these are non-metal. So two non-metal, they don't gain or lose electron, they share electron, and that's why it's a covalent compound. And for covalent compound, when you name it, you need a dioxide. Okay, but for ionic compound, you don't need a di, and therefore the correct name should be barium acetate. Okay, next one, sodium sulfide. Okay, note IDE. IDE is for monatomic ions. For example, fluorine. Okay, fluorine gain electron becomes fluoride. That's IDE. Okay, oxygen, when gain 2 electron, that becomes oxide. Okay, sulfur, when it gain 2 electron, so same group as oxygen, group 2 or group 6, it gain 2 electron becomes 8, and this is called sulfide. So that's the one. Okay, when you say sulfide, this is the one. All right, but what is SO3? SO3 is called sulfite. So SULFITE. Note that ITE. Okay, this comes from SO4 2 negative, and this is called sulfate, ATE. When this loses oxygen, becomes SO3 2 negative, and that's called sulfite. Okay, and so the problem is you should have IDE, so use this one. Okay, so the formula should be sodium sulfide. All right, now sulfide has 2 negative, sodium has 1 plus. You need 2 of them, and that's why you have 2 here. Okay, also when you name it, don't say disodium sulfide. It's a ionic compound, so just say sodium sulfide. In C, iron sulfate. The Roman number tells you iron has a charge 2 plus. Okay, sulfate is SO4 2 negative. Okay, because negative charge, positive charge equal, so the name should be only iron sulfate. So each have 1. Okay, instead of this one 2 and 3. So if you use this one, iron 2 sulfate 3, that indicates iron is 3 plus, and that's incorrect. Okay, the correct name should be this one. Next one, cesium carbonate. Cesium is a group 1 metal, cesium. The charge is 1 plus. Carbonate is a polyatomic ion, which has a 2 negative. Okay, so in order to balance the charge, you need 2 cesium. So correct name should be, a formula should be cesium 2 and carbonate. Now, do we need a parenthesis like here? Well, if you have more than one, then you do need it. For example, if you have a compound iron, if iron is 3 plus, then you need a parenthesis, and you need 3 of them, and here 2, so that 3 times 2, negative 2 times 3, and they balance each other. Okay, so you need 3. All right, you have a parenthesis, but here you only have 1 of them, so you only have 1 carbonate. You don't need a parenthesis. Okay, so correct formula should be cesium. You have 2 and carbonate 1. We know that hydrogen and chlorine forms compound called hydrogen chloride. Okay, note IDE, chloride. Now, when hydrogen chloride dissolves in water, it can lose the proton, or you can say it can donate the proton, and therefore it's called an acid. Okay, when a compound can donate proton, it's called acid. Okay, for acid, there is a special way to name it, and that is, in this case, it's called hydrochloric acid. So the rule is that you have a prefix hydro, and then the anion non-metal root plus ic, and then add acid. So hydrogen chloride becomes hydro, so hydro, not chloro, so chlorine, this is chlorine, so the root is chloro, and then chloro plus ic, and then acid. So hydrochloric acid. Okay, what about hydrogen and bromine? All right, if this is called hydrogen bromide, right? Hydrogen bromide, and when it dissolves in water, it becomes an acid called hydrobromic acid. Hydrobromic acid. In the last slide, we showed how to name binary acid. Sometimes acid contain a polyatomic ion. For example, here are a list of polyatomic ions. As we explained before, these ions based on this one, ClO3-, which is called chlorate, note ATE. All right, and when you have one more oxygen, it's called perchlorate. One less oxygen is called chlorite, ITE, and two less oxygen are called hyperchlorite. Okay, so I hope you remember this. Okay, if not, go over the material. Okay, try to remember, find the base, and then remember the rules. Okay, so note that all these polyatomic ion has a negative charge. To make a neutral compound, you need a positive charged ion. For example, proton. Proton is a positive charged ion. When proton combine with any of these polyatomic ion, they make a neutral compound. So here are the neutral compound. Everyone has a proton. In other words, they can donate a proton. This neutral compound can donate this proton. They are all called acid. Okay, because they have a proton to donate. Now, how do you name all these acids? Okay, these acids are called oxo acid because the anion has many oxygens. Okay, they come from oxo anions. Okay, they have oxyanions here. Okay, so the naming of these oxo acids, okay, are based on these oxo anions. All right, if the anion is ATE, then you change to ic. Okay, and then add acid. So here is the rule: ATE becomes ic. Now ITE becomes OUS. Okay, so here is the name. This one becomes chloric acid. Note ic. Okay, because this is ATE, so it's a chloric acid. Now this is chlorite, so it becomes chlorous acid. Hyper, per are retained, so this one is perchlorate, so perchlorate, and the ATE becomes ic, so perchloric acid. And this one is called hyperchlorite, so becomes hyperchlorous acid. All right. Now what about BrO4 minus? Now remember, bromine, chlorine, iodine, they are in the same group, and therefore they have the same form, and naming is the same. So when you look at the bromine BrO4 minus, you think about this one, okay? ClO4 minus, and this is called perchlorate, all right? And when you add a hydrogen, becomes perchloric acid. So this is perbromate, and add hydrogen becomes perbromic acid. Now what about IO2 minus? Well, you think about this one, ClO minus, ClO2 minus, this one, ClO2, which is chlorite, okay? Add hydrogen becomes chlorous acid. So this is iodide, ITE, and acid is called iodose acid. Sample problem 2.13. Name the following anions and give the name and the formula of the acid derived from each. So the first one is bromine with a negative charge, and this comes from bromine, and this anion becomes bromide, okay? The ending should be IDE. And when you add a hydrogen, it's hydrogen bromide. In water, it's an acid. The acid is called hydrobromic acid. So the rule for binary acid is you have a prefix hydro, and then IDE becomes ic, hydrobromic acid. Next one is polyatomic ion, and the name is iodate, ATE. Now, if you cannot recognize it, go to the polyatomic ion table and find ClO3 negative, and this is called chlorate, okay? And chlorate, chlor becomes iodate, so chlorate becomes iodate, okay? Now, when you add a hydrogen, you get acid, and the rule to name this acid is to change ATE to ic, okay, and do not add hydro. So the acid should be iodic acid, okay, iodic acid. Next one, Cn negative, all right, polyatomic ion. The name is cyanide, so IDE. Now, at first, you may not familiar with this polyatomic ion. You need to go back to the table and find them, and every time you practice, eventually you can remember these names. So it's cyanide. When you add a hydrogen, becomes acid. The naming is similar to the binary acid. You add hydro, so hydrocyanic acid, okay? And next one is polyatomic ion or oxyanion, and this is hydrogen sulfate, okay? So the anion is hydrogen sulfate. When you add the hydrogen, you get H2SO4, okay? The interesting thing is for this acid, you consider this come from sulfate, all right? For oxo acids, and the rule, okay, just like this one, you change ATE to ic, so the name is sulfuric acid, okay, sulfuric acid, because this is sulfate, ATE becomes ic, and do not add hydro. So hydro is for binary, all right, cyanide also, but not for oxo acids. We have learned how to name binary ionic compounds. For example, CaCl2. Okay, this is a ionic compound because you have a metal, you have a non-metal. Okay, the naming is you put a cation, which is a Ca2 plus first, which called as same as the metal, so calcium, and the second one is a non-metal anion. You use the root plus IDE, so chlorine becomes chloride, so calcium chloride. Okay, now what about a binary covalent compound. So again, let's use CO2. Okay, this is a covalent compound, also binary covalent compound. And so how do you name this one? So the rule is, because covalent compound doesn't have cation, anion, so which one go first? And you choose the element with the lower group number first. So in this case, carbon is group 4, oxygen is group 6. So group 4 first. So you name it carbon. The name remains unchanged. So it's still carbon. So that's similar to the ionic compound, but instead of cation, you use the group number. All right, and then the element that is the second, so oxygen, is named using the root with the suffix IDE. So that's also similar. So oxygen becomes oxide. Okay. Also, numerical prefix indicate the number of atoms. So in ionic compound, we don't use a prefix. So calcium chloride, but here you should carbon dioxide. So there are similarity and a difference. Okay, you need a prefix here. Okay, you choose the lower group number first, and the second one you need to use IDE. Sample problem 2.14. A. What is the formula of carbon disulfide? Carbon is C, sulfide comes from S, so it becomes anion IDE. Prefix di means 2, so CS2 should be the formula. Next one, what is the name? PCl5. P is phosphorus, Cl is chlorine. So to name it, we put the lower group number first. Phosphorus is group 5 and chlorine group 7. So the name should be phosphorus. Now, do we need prefix 5? It depends on whether this compound is ionic or covalent. Because both phosphorus, chlorine are non-metal, so it's a covalent compound. You need 5, and the chlorine becomes chloride, and therefore the name should be phosphorus pentachloride. Penta means 5. Okay, again, you need to first identify the compound is covalent, and then you can use penta. Otherwise, you don't need it for ionic compound. Next one, give the name and the formula for the compound whose molecules each consist of 2 nitrogen, N is the nitrogen, 4 oxygen, O is oxygen. So nitrogen you have 2, oxygen you have 4. Okay, which one go first? Nitrogen group 5, oxygen group 6, so nitrogen first, and therefore the formula should be N2O4. Sample problem 2.15. Explain what is wrong with the name and the formula at the end of each statement and correct it. A. SF4 is monosulfur pentafluoride. Okay, so first, do we need a prefix for the number? Well, we need to know if it's covalent or ionic. Since it's covalent, we do need prefix. However, for prefix should be tetra, not penta. So this is a mistake. Penta should be replaced by tetra. The other thing is mono shouldn't be used for the first atom. Even if the first atom only have one atom, you don't need mono for the first one. But you do need if it's the second one. For example, CO, so 1 oxygen, so you call carbon monoxide, carbon monoxide. Okay, you don't say monocarbon oxide. You only say carbon monoxide. The first atom, you don't use mono. Okay, so you have two mistakes in the first one. Next one, dichlorine heptaoxide is Cl2O6. So again, do we need the prefix? Because it's a covalent compound, so we do need them. And 2 is di, and hepta means 7, but this is 6, so it's wrong. So you should use 7, Cl2O7. Okay, so here the correct one should be Cl2O7. Next one, N2O3 is dinitro trioxide. Okay, so here is di, here is tri, so prefixes are correct. And first atom, you should name it the same name as the element itself. The second one you change it to IDE, but the first one you should keep the name. So when you say it should be dinitrogen, not nitrogen. First one you shouldn't change it, and therefore there's a mistake here. Nitrogen, dinitrogen trioxide. Okay, that's the correct one. And also, these two should have a space between them. So dinitrogen trioxide. In the future, you may learn organic chemistry. Organic chemistry are mainly based on carbon. The compounds contain only carbon and hydrogen are called hydrocarbons. Alkanes are the simplest type of hydrocarbon. Alkanes are named using the root name followed by suffix ane. Here are the first 10 straight chain alkanes. The first one, 1 carbon, 4 hydrogen. And the root is meth, and then add ane. So it's called methane. So methane has 1 carbon with 4 hydrogen. We have 2 carbon, okay, so 2 carbon with 6 hydrogen, the root is eth, then ane, so ethane. 3 carbon is called propane, ane, propane, and then 4 carbon, butane, okay, and 5 pentane, 6 hexane, 7 heptane, octane, nonane, decane. So from here to decane, these roots are similar to the prefix already learned. So penta means 5, hexa means 6, hepta 7, octa 8, nona 9, deca 10. So these are similar to the prefix. So these are different. So instead of mono, it's methane, and di becomes eth, ethane, and the tri should be propane, and tetra should be butane. Okay. We have learned atomic mass, which can be found from periodic table. What about mass of a molecule, or molecular mass? Molecular mass is the sum of atomic mass within the molecule. For example, a water molecule, the mass of this molecule, because the molecule has 2 hydrogen, 1 oxygen, so we have 2 times atomic mass of hydrogen, 1 times atomic mass of oxygen. So atomic mass of hydrogen can be found from periodic table 1.008 atomic mass unit. Okay, note that we read atomic mass with 4 significant figures, so 1.008. Oxygen is 16.00. These zeros are significant figures. Okay, so by doing that, we get 18.02 atomic mass unit. So the mass of one water molecule is 18.02 atomic mass unit. Now this is molecule, okay, the mass of molecule called molecular mass. What about the mass for ionic compound? Ionic compound does not have molecules. For example, sodium chloride is an array of sodium chloride, so infinite array. Okay, so you go 3-dimension. Negative charge adjacent to positive charge. But the ratio, the smallest ratio is called the formula mass. For sodium chloride, the ratio is 1:1, and that's why we can write sodium chloride, and that's the formula mass. Okay, so for ionic compound, we calculate the mass of this formula mass. Sample problem 2.16. Use the periodic table, calculate the molecular or formula mass of the following two compounds. So what given is the name, and our plan is we need to write the formula. And then we know how many atoms in a molecule or formula, so we can multiply the number of atoms, okay, by the respective atomic mass, and then add together, give you the mass for each compound. A. Tetraphosphorus trisulfide. So the molecule contains 4, tetra means 4, so 4 phosphorus, tri means 3, sulfide. So the formula or the molecule is P4S3. Okay, so the molecular mass should be 4 times atomic mass of phosphorus, 3 times atomic mass of sulfur. And from periodic table, you can easily find these numbers and plug in, and the answer is 220.09 atomic mass unit. Next one is ammonium nitrate. Ammonium is NH4 plus, nitrate is NO3 negative. Okay, so the formula should be ammonium nitrate. Note this is ionic compound. Ammonium is a cation, just like sodium, so and the anion, so that's a ionic compound. So the formula mass, now when you calculate, in fact, even though you write like this, you actually have 2 nitrogen, okay, 1, 2, so 2 nitrogen, 4 hydrogen, 3 oxygen. So when you calculate, you should use 2 times atomic mass of nitrogen, 4 times atomic mass of hydrogen, and 3 times atomic mass oxygen. Okay, and then find the atomic mass, plug in, answer 80.05 atomic mass unit. Sample problem 2.17. Each thing represents a binary compound. Determine its formula, name, and the molecular or formula mass. So if we look at the thing, clearly A is about an ionic compound and B is about a molecular compound. In A, you have an array of yellow and brown balls, means different cations, anions alternating from each other. So the yellow one is fluorine, the brown one is sodium. So you can see they are alternating. So it's sodium and fluorine. So sodium is a cation, so sodium and fluorine becomes fluoride. Okay, and therefore we can say that this is sodium fluoride. Okay, so to calculate the formula mass, okay, because it's sodium fluoride is 1:1 ratio. Okay, one is both are charge 1, positive 1, negative 1, so 1-to-1 ratio. Therefore, you can calculate formula mass by 1 times atomic mass sodium, 1 times atomic mass of fluorine, add together, give you the formula mass for sodium fluoride for A. Okay, so now let's look at B. And B is a molecular compound because you can see molecules. All right, these are the molecules. Each molecule, you have a nitrogen. So nitrogen is the blue one in the center, and then 3 fluorine. So this is fluorine. And therefore, you have nitrogen with 3 fluorine. And so fluorine must, well, this is a molecular compound, covalent bonds. But nitrogen is a group 5, fluorine group 7, so name should be nitrogen trifluoride. Okay, nitrogen trifluoride. And to calculate the molecular mass, then we use 1 times atomic mass of nitrogen, 3 times atomic mass of fluorine, and plug in the numbers, give you the molecular mass. Here shows the different ways to represent a molecule. We use water as an example. So H2O is a molecule, so formula. It's the formula of water molecule. And structure formula shows the bonding. So it shows hydrogen, oxygen, oxygen, hydrogen have 2 covalent bonds. So HOH with 2 bonds. The line represents a bond. And here shows the 2 electron sharing between hydrogen and oxygen. So again, it's a bond, but it shows 2 electrons there sharing between hydrogen and oxygen. So again, 2 covalent bonds. And this is actually a Lewis dot structure. And ball and stick model also tells you 2 bonds. All right, and the color tells you different atoms. So the center is oxygen. So for example, red represents oxygen, blue represents hydrogen. All right, now space filling model tells you now similar to ball and stick, but also tells you the relative size. So you can see oxygen is much greater size than hydrogen, and there's a overlap between oxygen and hydrogen. That's the bonding there. In the last slide, we used the ball and stick model and the space filling model to represent a molecule. In the models, we use colored balls to represent atoms. For example, a small blue ball represents a hydrogen atom. A black one represents carbon atom. A nitrogen one blue one represents nitrogen, and the red one represents oxygen. The relative size of these atoms are also represented by the relative size of these balls. So lithium is a atom much larger in size than other atoms represented here. At the beginning of this chapter, we learned mixtures, where 2 or more elements or compounds are intermingled together. There are 2 types of mixtures: heterogeneous mixture, homogeneous mixture. A heterogeneous mixture has 1 or more visible boundaries between the components. When sand is mixed with salt, okay, you get a mixture, and you can clearly see 2 different types of solids there. Homogeneous mixture has no visible boundary because the components are mixed as individual atoms, ions, or molecules. When sugar is dissolved in water, you get a mixture, okay, but you cannot see the difference, okay, because at the molecular level, there are 2 molecules, water molecule and the sugar molecule. So it's a mixture, but you cannot see the visible boundary, and that is a homogeneous mixture. A homogeneous mixture is also called a solution. Solutions in which water is the solvent are called aqueous solution. When sulfur element and iron are physically mixed together without chemical reaction, you get a mixture. Now in the mixture, sulfur remains as a sulfur atom or element, iron remains as iron, and these two can be physically separated. For example, if you apply magnets, iron will be attracted by the magnets. This way, iron can be separated from sulfur in this mixture. When sulfur and iron react, it forms a compound. So now it's not a mixture anymore, because sulfur becomes sulfide, iron becomes iron 2+, and so they forms an array of alternating positive negative charged ions. So that's a compound. In other words, sulfur is not the sulfur element, the atom anymore. Iron is not the iron metal anymore. It's iron plus iron. Okay, and therefore if you apply magnetic magnets, nothing come out. Iron will not, cation will not be attracted to the magnets, so you cannot separate them. The elements cannot be separated by physical means in compounds. Please read your textbook, Chapter 2. Practice with the follow-up problems and get ready with the homework assignment.